All right, we're doing our first experiment here. Lab 2, water and chemicals. How do they react? It's chemical reaction, probably going to see bubbles, could see a color change. We look for pH changes or the ever scary explosion. Hopefully we don't have too many of those. Let's go to our first one here. We're going to look at aluminum. Focus. Aluminum powder. And let's see what happens when we mix it with a little bit of water. So I got a little bit of water in here. It's really blurry. It's kind of stuck in here. Digging it out, little gray powder. Throw it in here. Mixing it around. Looks like a suspension. It's not really going in or doing anything. I don't see any bubbles. Let's check the pH, see if there's a pH change. Got some pH paper here. And if it turns red, it's an acid, turns kind of a blue color, it's base. And I would say it's staying neutral. Nothing happens when you mix metal, this aluminum metal, and water. Our next one, we're going to look at water and aluminum chloride. Nope, ammonium chloride, not aluminum. NH4Cl. Let's put a little bit in there. Whoa, oh my. A little heavy-handed there, but it's okay. It's actually getting cold in my hand. No bubbles. And it is starting to dissolve. So it is dissolving. Let's do a pH check. Not too many of these. No real pH change, surprisingly. No real pH change. I would say not much there. And next one is water and AlkaSeltzer. Comes as little tablets in this package. Fast relief, huh? Oh, wow, it is bubbling. If there's bubbles, there's a chemical reaction taking place. Oh yeah, I can hear it. I don't know if you guys can. See if there's a pH change. AlkaSeltzer is a mix of chemicals in there. Not much of a pH change. Lots of bubbles. Definitely a chemical reaction. Next, we have water with calcium as a metal. Calcium turnings. It's a metal. Put some in water. Uh-oh. Oh, that is, uh-oh, getting out of control. All right, I might have put too much in there. That is reacting a lot. It's very hot. Woo! Let's see what we got for a pH. Oh, that is super basic. Very basic. All right, I'm a little scared. I'm going to have to sign off here. I think I've caused a react. Calcium metal, very reactive. Lots of bubbles. Very hot. Probably should have put one piece in there. Next, we have water and calcium oxide. Calcium oxide. It's a nice white powder. So it's a lot of things. Boy, I was a little scared with the calcium. I wonder what's going to happen to calcium oxide. It's kind of a cloudy suspension. No bubbles, no fast reaction, no reaction here. Thumbs down on the reaction, unless there's a pH change. Let's take a look. Oh, something's going on. It's very basic. Very basic. So there is a little bit of a dissolving or something going on. Not dissolving very well. But the pH changed. So a little bit of solubility. I would say it's a weak electrolyte. No real chemical action. And it's having a hard time to dissolve. There's still a lot of powder at the bottom. So no chemical reaction, poor water solubility, but we did get enough to get a pH change in the basic area. Next, we have water and chalk, also called calcium carbonate. So here's some calcium carbonate. Mixing it with our water. Very cloudy. It's a suspension. Not really dissolving. No pH change. That's not doing anything. Okay, water and fructose. Let's see what happens. Fructose, another white powder. Fructose is a type of sugar, and it's dissolving. So that's soluble in water. Let's see if there's a pH change. No pH change. It should be red or blue. Next, we have water and honey. I can barely stand to watch what's going to happen here, but you know, we got to do the experiment. Bear with me. Come on, bear. Nope. I think you got plugged up here. Take the top off. Now, most of you may know what happens when you put honey in water. It does eventually dissolve. One of the key things we're going to look for here is if there's a pH change. As people have said, oh, sugar, that's acidic. And it can have an acidic effect on your body. Well, let's just put it to the test. So it is dissolving. No chemical reaction other than dissolving. pH paper. Well, then that's plain. No pH, no acidity, no alkalinity. It's neutral. Our next is water and isopropyl alcohol, also called rubbing alcohol. It is flammable. We're not going to run that experiment. We're just going to mix it with water. Oh yeah, that mixes perfectly. Very soluble together. Very soluble. Let's see if there's a pH change. Nope. No pH change. Next, we have water with magnesium. Water with magnesium. Here's magnesium. Not a white powder. Some little metal chunks. Not really seeing much of a reaction here. Let's mix them around. Didn't react like the calcium did, so that's good for safety. Let's see if there's a pH change. Nope. It's that nice, plain, kind of slightly off green color. That's just sitting there. No reaction. Next, we have water with Coca-Cola. I'm going with the original here. So that looks like it definitely dissolves. Don't even have to mix it. Cola's making a lot of water anyway. I don't know if you can see it is starting to turn reddish in here. So it is acidic. No reaction, but acidic with Coca-Cola. Next, we have water with soda lime. Soda lime is sodium hydroxide and calcium oxide. So we've done a little calcium oxide already. And we haven't done sodium hydroxide. Soda lime. Another white solid. Got in the granules here. It's having a hard time dissolving here. I'm going to try to crush it. Not really seeing much here. I had to break it up. Try to get. Now I know sodium hydroxide is soluble, but sodium, the other part, calcium hydroxide, is not. I'm going to say not really soluble there. No chemical reaction. See if it changed the pH. Oh yeah, very blue. Blue is basic. It's very alkaline, so that's the opposite acidic. So we do get a pH change, and some of it is dissolving. Yeah, next one is going to be water and starch. Starch for analysis from the American Chemical Society. Well, ACS certifications here. Another white powder. Anytime you see it's cloudy like that, it's not mixing very well. There are some ways to get starch soluble in water, but it usually requires heating. We're just mixing at room temperature. So not soluble. So does it change the pH? No. It has to be blue or red on there. Not doing it. Here, our next one is water and table salt, sodium chloride. Let's see what we're going to get. NaCl. Just drop some in there. I did this experiment for lab 3. I know this is lab 2. So it doesn't always go very fast, but it does dissolve. So soluble, no chemical reaction, no bubbles, no color change. Let's see if there's a pH change. Nope. Nope, no red. Yeah, or blue, no color change. Next up, we have water and urea. Some of you saying, oh, it's urea, gross. No, that's urine. Urea is a white powder, another white powder. Most things are white powders. It's an organic molecule. It is in urine. Great fertilizer. See, we're not getting the cloudy whiteness. Why? Because it is mixing. So soluble in water. See if there's a pH change. I would say no, not really. I'm not seeing blue. So not unless we put some more in there. What happens if we put some more? This one a little bit more in there. Kind of thought it might have a little bit of a pH change. Nope. No real color change there. So no pH change. Here, next one is water and vinegar. Vinegar. See what happens. Oh yeah, that mix is easy. Very soluble. No chemical reaction. Thumbs down. Is there a pH change? Let's take a look. Yes, that is starting to turn red. I don't know if you guys can see that, but it is turning red there. The other name for vinegar is not vinegar, is acetic acid. So it's definitely an acid. I got it diluted a little bit in here, but it's an acid. For our next one, we're going to do water and zinc. Zinc is a solid, shiny metal. Well, kind of shiny. See if we can get a piece out of there. Come on now. Well, definitely not exploding up like calcium. Kind of just sitting in there. No chemical reaction. Not soluble. pH change. Let's find out. No. Staying the same. No pH change. There's nothing there. That's it.